Hi, we are now ready for chapter 17, which is our fourth topic. So we're getting close to halfway there. Chapter 17 involves two separate topics that are combined together really for convenience. The first one is acid-base equilibria. So we're going to continue our discussion of acids and bases, but we're going to look at more complex solutions. So in chapter 16, we looked at primarily very simple systems like a strong acid solution. Let's find the pH of that solution or the percent ionization, for example. The strong bases, where we might find the pOH, and then from that, find the pH. Weak acids, where we had to introduce the idea of chemical equilibria in order to do those calculations, and with weak bases as well. So in chapter 17, what we're going to look at are a couple of different types of acid-base solutions. Then we'll look at what's called solubility equilibria, which if you recall from your first semester chemistry, you talked about something called, some people call them the solubility rules, other people call them the solubility guidelines. These ideas that some salts are soluble in water, others are not. And so we're going to look at the ones that we generally think of as not being particularly soluble in more detail, and we'll invoke the idea of chemical equilibria to describe them. So there's really two topics here. The number of sections isn't all that great, just about 5 sections that we're covering in here. But of those 5, some of them take a little bit of time. So it all begins with something called the common ion effect. So the common ion effect is a way of thinking about how adding a product of a reaction that's in equilibria, a reversible reaction, how that affects the equilibria. So you'll look at the common ion effect. And a very practical application of the common ion effect are what we call buffer solutions. Those of you who have taken biology courses, you're familiar with the idea of a buffer, a solution that seemingly magically resists changes in pH. So what we'll do in this course is we'll look in more detail at how buffers operate. What is the principles of equilibria that allow buffers to resist changes in pH? And by the way, they don't stop the pH from changing. The pH still changes. It's just that they reduce the change in the pH. So you look at buffers as well. Do some calculations with that, learn how to make them. Very practical information for a chemist or a biochemist. Then you'll get into acid-base titrations, and you might say, wait a minute, I did acid-base titrations in the previous course. Why am I doing them again? And again, what we'll do is we'll look at it from a more complicated, a more sophisticated method. We'll involve equilibria, but we can also now do something which you generally don't do in the first semester, which is you talk about pH. So we're going to look at pH curves for acid-base titrations. There are different types that can be done, these titrations. We will just look at a few of them: strong acid, strong base, weak acid, strong base, and strong acid, weak bases. And then we'll talk a little bit about indicators. So this is a pretty cool section. It does involve calculations, but the actual, what you get out of these calculations is pretty fascinating. Okay. So then once we finish up with that, we'll talk a little bit about acid-base indicators, which are these organic compounds, which are capable of changing color based on the pH of the solution. So you've heard of some of these. You've heard of phenolphthalein. It turns out that if you have red cabbage, so the dye or the pigment that is in red cabbage is actually a pH indicator. So you'll look at that. Then we get into the solubility equilibria, seemingly very different topic, but again, for convenience, it's in the same chapter. So we'll look again at taking solubility and applying the principles of equilibria to solubility. So it turns out that for slightly soluble compounds, we can express the solubility as an equilibrium constant, which we call the solubility product, KSP. It is an equilibrium constant just like any other, and so that allows us to do some equilibrium calculations. Okay, So we'll look at the solubility product, then we'll look at the common ion effect as it portends or as it is related to the solubility of compounds. So we'll look at the common ion effect, apply it again. You apply it with buffers, now you apply it with solubility equilibria. And so we'll look at that as well. And then for those of you that are interested in it, there's also this idea of complex ion formation, which is an important topic. We're not going to do a whole lot on that. We're just going to kind of introduce complex ion formation, but that'll be pretty much the end of the chapter. Okay, so again, pace is very rapid, but I looked over people's scores for exam 3 and it was very good. A lot of high scores in exam 3. So don't be fooled by it. The material in 17 is a little bit more complex and it's going to be based on what you learned in 16. So keep at it, keep working on it, and good luck. Reach out to me if you have any questions.